Hey everyone, I wanted to show you an example from the lab on Friday, what you're responsible for. This is one of the precipitates that formed. I think most groups had 5 or 6 precipitates form, and you're responsible for 3 things for each. So I just wanted to give you an example. My apologies for the camera, by the way. I'm at home on a really jerry-rigged setup because I didn't get a chance to do it at the dock cam. So let's go ahead and get started here. We have silver nitrate and sodium chloride form a precipitate. So put those two solutions together, and I think on Friday we saw something form out of that. So you're responsible for 3 things: balanced equation, overall ionic, and the net ionic. So we got to do those 3 things. This is just one of them that you'd have to do. Let's see, I'm jittery. I've had a lot of coffee, so let's see how this goes. So the first thing I want to do is the balanced equation. That's going to require me to know my charges of everything. Nitrate is a polyatomic ion. I looked that one up beforehand. Nitrate has a -1 charge, which must mean silver here has a +1 charge. Sodium chloride over here, pretty familiar with this one. +1, -1 charge. So now that I know those, I can just do the balance equation. Balance equation does not care about what precipitate formed. That's where we get to overall ionic and net ionic equation. And this is also where we use the solubility rules type of stuff, chart that I gave you. So starting off here, the balance equation, all I have to do is just switch my anions and my cations. So start off with the reactant side. And we are now keeping in mind the state that each of these are in. So both of those were aqueous state, meaning they were dissolved in water. And then we are going to go to switch our anions and our cations. So we have AgCl and NaNO3. Now I got to talk about the state of these as well. I had the state of these. But I'm not making any guesses just yet until I talk about the overall ionic equation and the net ionic equation as far as what the solid was that formed in this precipitate. It's going to be one of these two, but let's get to step 2. Before we do that, we have to make sure everything's balanced here. So I didn't have to put any parentheses or subscript or anything because this already had a +1 and a -1 charge. This already had a +1 and a -1 charge. So like, let's say if this was calcium, had a +2 charge, I would have had to put a parentheses around nitrate and a 2 down there. But everything as far as the molecules themselves are balanced out. So we're happy with that. Also, we're happy with balancing the equation with any coefficients that go in front of them, because everything, there's one of them. There's 1 silver, 1 nitrate over here, 1 silver, 1 nitrate, etc., etc. So this is the balance equation. I'm going to fill in my states here in a second once I get to number 2, overall ionic equation. So this is where we spread things out with the charges, look at the solubility rules, and figure out what precipitate had formed. And we're once again going to use the solubility rules. I have it in front of me with the computer. If you want to have that in front of you as well, that would be of help, of assistance. Okay, so yes, these are compounds that are together, but they're dissolved in water, which means effectively they're just spaced all out. So really what it looks like, and this is, I suppose, a more accurate portrayal of what is going on when we do the chemical equation, plus Na plus So that is really what the products, the reactant side looks like chemically when we're just put the 2 solutions together. So this is where I look at the solubility rules in front of me, and I'm going to decide which of these 2 ions are going to get together and form a solid, and which 2 are just floating around. So I'm looking at the solubility rules, and it says that nitrate never forms a insoluble compound. So that's not going to be part of it. That's not going to be part of the solid. It also says chlorine here. I see chlorine says it is a soluble ionic compound except for a few cases being silver, mercury, and lead. So, wait a second. So chlorine is soluble except for in the presence of silver when it would form an insoluble compound. So I'm looking at that saying, sweet, that must be the precipitate. So over on the product side, I'm going to do this. So there is our precipitate. And what that means is sodium's not doing anything, nitrate's not doing anything. So over here, I'm just going to put plus NO3 minus plus Na plus. So that allows me to go back up here and fill in that, let's see, that silver chloride is the solid and this is aqueous. So this is the balanced chemical equation, but this is really the nitty-gritty, the nuts and bolts of what's going on here. AQ, AQ. And if you analyze this at the end of the reaction, what this is saying is that silver chloride forms a precipitate, while nitrate and the sodium ions are just really floating around, hanging out there, because they usually don't form any sort of insoluble compounds according to the solubility rules table that I gave you. Okay, so that is the overall ionic equation. Once again, no balancing needed, but if, like, let's say if this had some weird, I had to put some subscript 2, something like that, I would have to go back and balance out. Okay. Number 3, net ionic equation. Net ionic equation is really just like, all right, get to the point here. What exactly do we have going on? So that eliminates any sort of ions that didn't form anything in step 2. So I'm basically just going to take silver and chlorine, positive, negative, AQ, AQ. So that is our reactants. Our products is AgCl. And that one was really easy, because I basically just did a shortened up version of number 2 there. Alright, so let me look back here, see how happy I am. Now, I didn't have to do any balancing or anything like that in this one. We've talked about those a few times, but really pay attention to your charges, because you may have to, like, let's say if this was, what could I put here instead? Sure, fluorine, whatever. I don't even know if that balances it. But let's say this is actually, oxygen. Yeah, let's say this is oxygen right here. And that would be a negative 2 charge. Then I'd have to go over and say, oh, well, there's a negative 2 charge here, only a positive 1 charge here. So I would have to balance out my silver like that. So keep in mind the subscripts type of stuff. Then I'd have to balance the chemical equation, make sure everything's happy, conservation of mass type of stuff. So, yeah, so this one, this really was at the end of the day. Let me write this one more time just so you have the overall picture. Number 3 was Ag plus Cl. So that's the correct number 3, the correct number 2, the correct number 1. I think this is probably a freebie because I'm pretty sure this formed a precipitate. So enjoy. Let me know on Remind if you have any questions, and also, keep in mind balancing molecules and balancing the equation overall, because I actually picked kind of an easy one where I didn't have to do any of that. But balanced chemical equation, overall ionic equation, and net ionic equation. So that's 1, 2, and 3 for one of the precipitates that formed. You have to do that a bunch of times, though, and it's good practice. So I will see you on Tuesday, or I will see you on Remind once you watch this and have questions. Talk to you soon.